Same sorted array. 2, 5, 8, 12, 16, 23, 38, 56. This time the question is slightly different. For a target of 16, what is the first position whose value is strictly greater than 16? That is 23, sitting at index 5. Notice how this differs from lower bound, which would have stopped at 16 itself. Upper bound is lower bound with one tiny change. Because the array is sorted, we still have the window each step. We look at the middle. If it is less than or equal to the target, it is not strictly greater. So the answer lies further right, and we move low past the middle. Otherwise, the middle is bigger than the target and could be the very first such value. So we keep it and shrink high. When the markers meet, low points at the first value that beats the target. The only difference from lower bound is the comparison. Here we ask whether the middle value is less than or equal to the target. If it is, even equal counts as not strictly greater, so we move low up past the middle. Otherwise, we pull high down to the middle. When they meet, low is the upper bound. Let's build upper bound live and watch how one comparison changes everything. Low starts at 0 and high at the length of the array, just past the last index. While the window is not empty, look at the middle position. If the middle value is at most the target, it is not strictly greater, so move low to the right. Otherwise, the middle might be the first value that beats the target, so keep it, then return low at the end. Now, let's test it and hit run. Look at the difference. For 15, the first bigger value is 16 at index 4. For 16, upper bound steps past it to 23 at index 5. And 56 is the largest, so we land at index 8, just past the end. The shape is identical to lower bound, only the test changes. Set low to 0 and high to n. While low is below high, take the middle. If the middle value is at most the target, move low up. Otherwise, move high down. When they meet, return low. Just like lower bound, every step discards half the remaining positions, so we finish in a number of steps that grows like the logarithm of the length. Order log n time, and order one space for the two markers. 3 things to remember. First, upper bound is exactly lower bound with a less than or equal test instead of a strict less than. Second, upper bound minus lower bound is a lovely trick. It counts how many times the target appears. Third, if the target is the biggest value, upper bound returns the array length, meaning nothing is larger.